Hi, today we're going to go through a Webquest on covalent bonding. Now we have not talked about covalent bonding yet, so this Webquest will be very important for you to make sure you really pay attention because it is different from ionic, so you need to make sure you understand exactly how. It is actually easier to name and write the formulas for the compounds. You don't have to worry about a method to use to come up with a name or the formula. In the ionic bonding we could use the crisscross formula or the dot diagram formula. But with covalent you don't have to worry about that, and there's a reason why, and we'll get into that in just a little bit. So we'll do this the same way we did before. You have your questions and I will give you a prompt when to answer the questions. I'll be reading through each slide and carrying out the Webquest as you read along. Okay, here we go. Covalent bonding is typically explained as a bond that forms when atoms are sharing electrons. In this tutorial, we'll explore what this means and how the process of sharing electrons can hold two atoms together. Okay, so answer question number 1. And remember to pause when you start to answer the question so that you'll have enough time. Before we start explaining how covalent bonds work, let's experiment with two atoms that will form a covalent bond to see what happens. There are two hydrogen atoms in the box below. Try moving them around to see how they interact with each other. Okay, so I'm going to do that. So bring them close. Alright. I'm going to try to get them really close, but they don't seem to want to do that. Okay, now I'm going to pull. Now that I've got them this close, it's hard to pull them away from each other as well. Okay. Before you continue, be sure you know the answers to the following questions. How is the movement of the electrons different when the atoms are close? What happens if you try to move the atoms very close to each other? Okay, so now you can answer question number 2. Let's look at what is happening in a couple of different ways. In the image below, a line has been added showing the attraction that the nucleus on the left has for its own electron. The atom on the right has the same attraction for its own electron, but it's not being shown. When the two atoms get close enough to each other, we begin to see the nucleus on the left weakly attracting the other atom's electron. So they're trying to actually attract each other's electron. When the two atoms get even closer, the nucleus on the left has a strong attraction for both its own electron and the electron from the other atom. At this point, both atoms are attracting both electrons. We can see that the electrons spend almost all of their time between the two nuclei. Now you can answer question number 3. If we also show the attractions from the other nucleus, we can see that it is also pulling on both electrons. This is a covalent bond. The atoms are not really sharing electrons as much as they are fighting over them. They are both trying to attract the same electrons, but neither one can actually take them away from the other. This creates a situation in which both atoms are stuck together. Now you can answer question number 4. Let's take a moment and look at what kinds of atoms will form covalent bonds. Earlier, we saw that in order to form a covalent bond, both atoms must be able to attract another atom's electrons while still holding on to their own. Using the periodic table below, click on the region where you think atoms with these qualities would be found. Okay, so let's click on this part. Okay, sorry, not metals don't hold on to their electrons very well. That's why they form positive ions and are good conductors. Okay, you can answer question number 5. Okay, let's click over here, the noble gases. Sorry, the noble gases almost never form bonds. They have a strong attraction for their own electrons, but don't tend to take electrons from other atoms. Now you can answer question number 6. Okay, so let's try the metals. You got it. Non-metals tend to be good at taking electrons from other atoms. Now you can answer question number 7. So we can generalize that covalent bonds will form between two nonmetals. Each of the nonmetal atoms will have a strong attraction for the other atom's electrons, but will also tend to hold on to its own electrons. Now you can answer question number 8. Note that hydrogen is considered a nonmetal and will form covalent bonds with other nonmetals. You can answer question number 9. Now let's take a look at the covalent bond from another point of view. How is energy involved in the formation of a covalent bond? In the next few screens, we will look at the energy aspects of covalent bonds. Try slowly moving the nucleus on the right closer to the nucleus on the left. Okay, now I'm going to do that, and you watch the graph as I do that. Here we go. Okay, I'm going to try to push them together, but okay. You should notice a couple of things from this graph. As the atoms move closer to each other, the potential energy decreases. This is because each nucleus is attracting the other atom's electron more and more strongly. You should also notice after a certain point, the potential energy increases if you try to move the atoms any closer. This is because the protons in each nucleus are repelling each other. When the atoms are arranged so that the potential energy is at a minimum, they have achieved the most stable balance between the attractions and repulsions that are occurring. The distance between the atoms at this point is the bond length. Okay, now you can answer question number 10. The point at which these atoms are lowest in potential energy is where they are most stable. In other words, the atoms are more stable when they are bonded together than when they are apart. You can answer question 11. You will find that this idea is repeated in other areas of chemistry. Lower in energy equals more stable. When we draw pictures of molecules, we often use a single solid line to represent the pair of electrons that are being shared. This is shown below. Okay, you can answer question number 12. Some atoms will form covalent bonds by sharing more than a single pair of electrons. Oxygen atoms, for example, share 2 pairs of electrons when they bond. We call this a double bond. It represents a total of 4 shared electrons. You can answer questions 13, 14, and 15. Nitrogen atoms must share 3 pairs of electrons in order to form a covalent bond. We call this a triple bond. It represents a total of 6 shared electrons. Now you can answer question number 16. If we compare these types of covalent bonds, we find out the following. Single bonds tend to be the weakest of the 3 types. Triple bonds tend to be the strongest of the 3 types. In the final part of this tutorial, we will take a look at how we assign names to simple covalent compounds. Examine the list of covalent compounds and their names below. See if you can find any patterns in how they are named. Okay, so I'll read the names out loud and you look at the formula. Nitrogen dioxide, right there. Okay, dinitrogen trioxide, carbon tetrachloride, dichlorine monoxide, and disulfur chloride. One thing you should notice is that the ending of the name of the second element has been changed to IDE. For example, oxygen has been changed to oxide and chlorine has been changed to chloride. Now you can answer question number 17. Another thing you should notice is that the prefixes have been added to many of the elements' names. You can answer question number 18. These prefixes are added in front of each element's name to tell us how many atoms of that element are present in the molecule. For example, in the first compound, the prefix di is used to tell us that there are 2 oxygen atoms. You can see 1 nitrogen and 2 oxygen, the O2. The 2 goes with the oxygen. When you don't see a subscript, you assume a 1, but 1s are not written for subscripts. Now you can answer question number 29. The following prefixes are used in covalent compounds. Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6. The only exception to the use of prefixes is that we never use the prefix mono if there is only 1 atom of the first element. You'll notice that there is no prefix in front of nitrogen in the first compound's name. So if you look over here, you do not see in the name mononitrogen dioxide, even though there's 1 nitrogen. But do notice down here, the mono is used with the second element. Dichlorine, you see 2 chlorines, and then 1 oxygen, so you see monoxide. Usually we drop one of the O's when it comes with the oxygen. So instead of monooxide, you'll see monoxide. So we do not use mono only if mono comes with the first element. But if mono needs to come with the second element, we keep it. That's just one of the rules of naming covalent compounds. You can now answer question number 20. Let's try a few to see if we understand. Drag each name into the box next to its formula. Now I'm going to go kind of slow, so I want you to see if you can do it in your head while I'm doing it for us here on the screen. N2O, that means there's 2 nitrogens, 1 oxygen. So I know that di means 2, and 1 oxygen, that's mono, so I think this is it right here. Dinitrogen monoxide. Okay, NO2, so I have 1 nitrogen, 2 oxygens. Now I know that mono means 1, but remember that we don't use it on the first element, so I'm just going to look for nitrogen. Okay, there's nitrogen monoxide, and there's nitrogen dioxide. Well, there's 2 oxygens, so I know di means 2, so I think I'm going to pull that over here. Yep. N2O4. Alright, I know di means 2, 2 nitrogens. 4 is tetra. There's 4 oxygens. So I'm going to see the di with a nitrogen. So there's a dinitrogen. Tetroxide. And here's dinitrogen trioxide. Well, I know that tri means 3. Think about triangle and tricycle. Okay, tetra means 4. So I think it's this. Alright, so here we have N2O3. Once again, dinitrogen, and then the 3 oxygens would be a trioxide. Remember, prefix means it's going to come on the beginning of the name. Alright, then NO. Well, if you don't see subscripts, what do you assume? That they're 1s, okay? So we know mono means 1, but I will not see a mono with the first element. I will see mono with the second element if it needs it. And sure enough,